In this video I'm going to talk about trig ratios. If you've taken a geometry class, you should know what that term means. Trig ratios are simply how you relate the side lengths of a right triangle. This is a right triangle, and how that relates to our trig functions. So I'm going to write at the top something that we are going to need, and that is SOHCAHTOA. I'm going to use SOHCAHTOA to get the first three trig ratios, and then I'm going to know the reciprocal identities to get the other three. So if I have this triangle here and I want to know what are the trig ratios of the angle theta. So there's my reference angle. It's down here in the bottom left. Okay, we got to make sure we're referencing from the correct angle here. I'll start with sine. The sine of the angle theta is the opposite over the hypotenuse. So that's going to be 3/5. The cosine of the angle theta is the adjacent over the hypotenuse, which would be 4/5. And the tangent of the angle theta is the opposite over the adjacent, so that's 3/4. So there are three of our trig ratios. Those are the three common ones. And then we should know at this point that we do have three other trig functions. We have cosecant. The cosecant is the reciprocal of sine, which means it's hypotenuse over opposite, which would be 5/3. The secant is the reciprocal of cosine, so that means it is hypotenuse over adjacent, 5/4. And the cotangent is the reciprocal of tangent, which means it is adjacent over opposite. And there are our 6 trig ratios of that given triangle. Okay. Now I want to be clear here, we did not figure out what the angle measure theta was. I have no idea what that angle is. What I do know is that the sine of that angle is 3/5, and the cosine of that angle is 4/5, and so on. Okay. Number 2, if the cosine of the angle theta is 5/13, sketch a right triangle with that angle, and then find the other 5 trig ratios. So I'm going to draw a right triangle, not to scale here. I'm going to put my angle theta in one of the acute angles. It really doesn't matter which one when you make your sketch. The cosine of the angle theta is 5/13, which means the adjacent side is 5 and the hypotenuse is 13. So if I want to find the other trig ratios, I need to know what the other side length is. So I'm going to have to do a little bit of work to get that, which is going to be the Pythagorean theorem. So essentially what I have here is that whatever that side length squared is plus 5 squared has to equal 13 squared. Right? It's got to fit the Pythagorean theorem. So x squared plus 25 has to equal 169. So x squared would have to be 144, which means that x is 12. So there's my side length, it's 12. Well, then I can find all of these ratios. The sine of the angle theta is the opposite over the hypotenuse, so that's 12/13. The tangent of the angle theta is the opposite, 12 over the adjacent, which is 5. The cosecant is the reciprocal of sine, so that's 13/12. The secant is the reciprocal of cosine. Cosine was given, so that's going to be 13/5. And the cotangent is the reciprocal of tangent, so that's going to be 5/12. And that is how you find trig ratios of right triangles.